Whatever that was. Okay, let's look at a problem that we did one of in class, and it's kind of one of the last ones on our sheet. It is a relative motion problem. So let's look at one of these. This is the Unit 4 problem number 45, and Austin, I think you just became the new boss. Congratulations, you're the mini boss. The cat went crazy. You're in charge now. We'll see if anybody usurps the throne. Congratulations once again. But this is Unit 4 problem. One of the further ones, 45. And this is actually relative motion. You recognize now, Austin, that for 1,000 years when this video is watched, people will know that you were the first person that took down a mini-boss. What an accomplishment. Okay, so in this problem, we're looking at the problem, and it reads, the pilot of an airplane wishes to fly due north, but there's a 75 km/h wind blowing towards the east. In what direction should the pilot head her plane if its speed relative to the air is 310 km/h? Okay, so basically here, ooh, what's this? What we're looking at is this. We have our axis system. And remember, north, south, east, west. And what the pilot wants to do here, what our ultimate goal is, our goal is to head directly north. We're shooting for this. Okay? This is what we want. But we've got a few things to deal with. The wind is pushing due east, okay? And the wind is actually pushing at 75 km/h. If we kind of think about this scenario, we want to head north, but the wind is pushing us to the east. How would we kind of point the nose of our plane in order to go in that northern direction? Well, if we just kind of think about this a little bit, if we're being pushed to the east, if we're being pushed to the right, we need to fight back into that wind. So we know that we kind of want our plane to be flying somewhere over here. Okay, that's how we want our plane to be kind of traveling, because the wind's going to push us back, it's going to turn us, we're going to be going north. So with these three vectors, we need to ask ourselves, what kind of triangle can we make? Now, if you're looking at the screen, maybe you see the triangle, but let's just think about it for a second. Okay, if we try to take these three vectors and add two of them with the head-tail method, the third one needs to give us the resultant. Okay, so what we're going to do is we're going to add two vectors, and we're going to get the resultant vector out of it. So let's just do this real quick. Let's pretend what happens. If we add the north vector, which we want, plus the wind going to the right, our resultant is going this way. Is that purple line in the same direction as the purpley pink line we drew before? No, clearly not. So that's garbage. That's not what we want. That doesn't physically make sense. If we draw the north direction followed with the head-tail method by the kind of purple magenta direction, we get this. And then we ask ourselves the question, is this blue wind the same as the blue wind going horizontally? No, that's garbage too. The only way that actually makes sense is if we take the magenta direction and then we add to that the wind. Well, start to finish, we get our triangle. That's what we want. Now notice here, I haven't done any actual calculus or any trig or anything. I've just done nothing here. What's up, Devin? we've just set up a triangle. Okay, but that triangle tells us a lot there. And we can play SOHCAHTOA with it. Basically, we have 75 for that side there. And then the other thing in this problem we need to think about is we were given that the plane is traveling 310 kilometers per hour relative to the air. So the question becomes this: if it's going relative to the air, well, if there was no wind, that plane would be going 310, no matter what, in any direction it was flying. Well, this is the direction the plane is flying. That's its airspeed. That is actually 310 kilometers per hour. So this is 310 kilometers per hour right here. Now in this problem, we are asked what direction is the plane flying. And if we're asking what direction is the plane flying, or what direction should the pilot head her plane if it's relative to the air, then what we're trying to do here is, if this is kind of a mini axis, just like it was over here, we're trying to find the angle at which the pilot is flying. Now, slight little thing here. We always find our polar angle from the positive x-axis. Pilots, and if you ever want to go be a pilot, this kind of thing, pilots find their angle from north. Okay, so technically, you know, if you want to get all piloty on me, technically our pilot is finding this little angle right here. But for all intents and purposes of this class, let's find our polar angle like that. Anytime we're trying to find an angle, what we're going to be using is we're going to be using an inverse function. Okay, so anytime we're looking for an angle, inverse function. And in this case, looking at our triangle here, this is our opposite side, this is our adjacent, and this is our hypotenuse. So if we have the opposite and the hypotenuse, and we invoke the great name of SOHCAHTOA, SOHCAHTOA, we should recognize that we have an opposite and a hypotenuse. We're using sine. So we can say theta equals the inverse sine, or the arc sine, depending on who you've got teaching you, of the opposite, 75, divided by the hypotenuse, 310. If you bust out your great calculator, you make sure that sucker is in degrees, and you just punch that in real quick. We find that our angle here is 14 degrees. In this case, and what the answer that we kind of have here is, we could call this 14 degrees west of north, because if this is the north direction, we're going west of that. If we were given this in a polar notation, that would be 90 plus 14, which would be 104 degrees. So kind of a few different ways to talk about that, but that's the direction we're looking for in a problem of this type. Okay, so that's what's going on there. Looking at a problem with relative velocities. So just something to keep in mind there as you're looking at it. Really, the big thing in this problem was how can we set up our triangle? That's the tricky part. Okay, and if you can set up that triangle, you're all set to do a problem like this. The rest of it's just a little bit of SOHCAHTOA. Okay, so with that, this problem is finished. Devin Kraft. It's from the 724.